Hello everyone. Today we are going to solve the second problem of dynamic programming, and the problem name is minimizing coins. Let me read the problem statement first. And the problem is, consider a money system consisting of n coins. Each coin has a positive integer value. Your task is to produce a sum of money x using the available coins in such a way that the number of coins is minimum. Okay, for example, this is the example given to us. So the minimum number of coins we have to find. If it is not possible, then we can print -1. So the example, let me explain the problem statement. Okay, so we are given with k equal to 11. Okay, so we have to use the denominations of such coins to make the sum equal to 11. Okay, we have to use the minimum number of coins to make the sum 11. So the answer to this problem is we can use 5 plus 5 plus 1 is equals to 11. Okay. So we are given that we have infinite amount of denominations of a particular coin. Yes, it is given that in the problem statement. Okay. So I think the problem statement is clear to everyone. So let's move to the solution. So in order to solve the problem statement, first we have to define the states of dp. dp of I represents the minimum number of denominations required to make the sum equal to I. Basically it means that to make the sum equal to I, the minimum number of denominations used of each type. Okay, so dp of I represent this. Now we will define the dp of I. So let's move to the transition part. To understand the transition, first we have to understand the memorization approach to this problem. Okay, so let me again copy this. Just a second. Let me again copy this. Okay, so yes, so we have to make the sum equal to 11. We have only two options. First is take, or second is non-take. Not take is already clear to everyone. We will skip this element and move to the I plus 1 part, right? Okay, so in the take operation, now the first operation is clear to everyone. Okay, so we will talk about second operation, take operation. Now we have 1 5 and 7. 1 5 and 7. If I take this element, I can only take this element if my k is greater than or equal to this denominations. Like we need k to be 0, right? K is equal to 11. Okay, we need k is equals to 0 because we have to fulfill the requirement of problem. Okay, so we need k is equals to 0. If k is greater than or equal to v of index, like I can use first index, I can use this element if and only if k is greater than or equal to this element, right? Yes, so I think this much is clear to everyone. So if my k is greater than or equal to v of index, uh, k is greater than v of index, then I can move take is equals to 1 plus get of index -1. Okay, v of index, uh, v and dp. Okay, so most of you wonder why will we not do index minus 1. We will not do index minus 1 because we can use multiple times of v of index. Like I can use 5 two times, to get the sum of 11, right? Plus 1 is equals to 11. Yes, uh, in this 5 is using 2 times, so we cannot shift the index. We will remain at this position. So index, we will remain at this index. We will not do index minus 1, and 1 is basically we adding one operation to our answer. Okay, let me show you the code. It will be much better if I will directly show you the code. So yes, this is the code, memoization code. Okay. So we will take input n and k vector. So we will declare a dp vector of n and k plus 1, initializing with minus 1. We will call a function with n minus 1, last index, required sum, v and dp. Okay, so if k is equals to 0, then I will return 0. It means my condition is fulfilled now. If index less than 0, it means that I will go a outbound situation. So I will return integer max, and then it will not take function index minus 1 k v dp. Okay, so I will declare take is equals to int max, and v of index is less than or equal to k. uh, yes, I hope this understands everyone. So I will apply one operation, and the remaining sum would be k minus v of index, and we will move again. So we will take the minimum of take comma non-take. Let's move to the memoization part, which is really important to solve the problem completely. uh, it's better if we use dp vector with first dp. Like we can define only dp vector with n with k plus 1. Okay, initializing with 0. So to memorize this code, we will run two for loops, which initially run from 0 to till k, and second loop will go from 0 till n. Okay, so basically first loop represents, just a second. Yes, let me change the color. Okay, so first loop represents, to make the sum equal to I, we have to choose between the array. Like for the ith element, to make the sum equal to I, we can choose 1, 5, 7, 8, anything in this vector. Okay, but we can only choose 1, 5, 7, 8 only and only if my I is greater than or equal to v of j. Right or wrong? Right. Okay, so let me write the condition. If I is greater than or equal to v of j, then I can select if, okay, if now my dp of I is dp 1 plus dp of I minus v of j, right? So yes, this is our tabulation code. So guys, think about it, and our final answer would be stored in dp of n, dp of k, actually dp of k, final answer. Okay, so let me show you the code of this problem. which is completely, yes, yes, dp of 0 is equals to 0, which is our base case. Yes, to make the sum equal to 0 we have 0 ways. We have zero coins, right? To make the sum equal to 0 we have 0 options. So we will run a loop from 1 till x and j 0 till n. If I is greater than or equal to v of j, then we will take the minimum of dp of I minus v of j plus 1, and yes, that's it. Okay, so if dp of x is equals to 1e18, I will return minus 1. This means that the answer cannot be found. Like I was not able to make it 11 by choosing some elements in the array. Okay, so I hope this much is clear to everyone. Thank you very much guys for watching this video.